Good evening, students. Good evening, sweetie. Good evening, students from Bagalkot. Good evening, students from North Canada. How are you all? Had your food? Is your health pretty good? Everyone is taking care of their health, right? And students from YouTube Live, good evening. I hope you're also well. Had your tea, everyone? So I'll be waiting for 2 more minutes, then we'll start our session. Okay. In the meantime, make sure that you have your copies ready, you have pen and paper, everything is ready. Is it good? Today, mostly we'll be solving problems. So make sure that you have your pen. Let's say if you, if you want to use a calculator, you can use, but I wouldn't recommend. But a calculator is not necessary. Good. So, okay, in the meantime, let's do one thing. Let's launch the technical poll. As I can see less people. So please, students, can you let me know through the chat that is my audio and is my presentation visible or not? Okay. It would be really helpful if you say it. Let me know, students. Okay, good. Thank you. Thank you, sweetie. Let me know from Bagalkot and North Canada students. So it will be really helpful. It's okay even if you send me a thumbs up. Okay. Okay. So students who are joining now, please let me know, is my audio, is my presentation visible or not? Good evening, Parth. Can you see my presentation? Yes. Awesome. I hope you can see my video too. Just a second. Okay. Good. Okay. So good evening all. How are you all? Okay. So my name is Samanvit. I hope you are able to recognize who I am now. So I'm your physics faculty over here, and I work as a program associate in Avantifellows. Okay, and program associate in physics. Path, what do you think? How many? What's my age? What's my age? What do you think? Let's say you guess the age. Do I look small? That small? 24, 28. Okay. So my age is 26, Path. Okay, my age is 26. Is it good? Is it good, Path? Do I look young or do I look let's say old? So good evening all. Abhay, Sweetie, Sandeep, Suman. Yeah. Good evening, Suman. Okay. Okay, Parth. I wouldn't say loudly that. Okay, then it would be what you say, praising myself. Good evening, Abhay. Okay, students. So the time is up. So let's start our session. And what were we talking about? We were talking about Newton's laws of motion. In the last class, we have studied a lot of things. So don't worry, we'll go to the recall of those sessions. Okay, the last session. So in the meantime, let us go to the contents of today's session. What we are going to talk about today, okay, in this session. So first of all is the basic thing, that is what we quickly recall last class subjects, okay, last class topics, basically topics. Then there will be a quick question for you guys. Okay, that question is a question where I asked you to try it. I hope everyone has tried it. If not, I'll solve it. Okay, today also I'll give you time to solve it if you haven't solved it. Okay, then we'll go into numericals based on FBD. Okay, based on FBD. So these questions are to make sure that you have understood free body diagram, how to solve for tensions. In this numerical, you basically solve for tensions. Okay, then there is something called rotation of axis concept. Okay, let's say right now you are seeing, let's say, force in, let's say you have two axes, x and y. You know that Now, what happens if you rotate the axis? Then how do you calculate? Okay, this let me use this. If I rotate the axis x dash and what y dash by an angle theta, then how can you solve the problem? So we are going to talk about that too. Then, not the least, we are going to talk about the today's session. That is summary of today's session. Is it good? So, students, are you ready for today's session? Let me know. Let me know with the thumbs up, everyone. Okay, good, awesome. Okay, nice. Okay, nice. Good, good. Okay. So, what we are going to talk about recall. That is what yesterday's session, what and all we have talked about. Do you remember what did we talk about? We talked about what? Free body diagram. Yes or no? What did we say? See, what is the necessary of free body diagram? Can anyone say? What is the necessity of free body diagram? Can anyone say? Any students, JNV students, North Canara, Bagalpur students, North Canara? Yeah? Or anyone else, Abhay, Suman, Sandeep? The need was what? Let's say for a body, there might be number of forces acting. Yes or no? Number of forces acting on the body. And we want to know how they act, how many they act, yes or no? How many they act, yes or no? And from which directions they act, yes or no, students? For that reason, we wanted to draw, yes, very good. We wanted to draw a free body diagram of a system, yes or no? Here we told that there are certain assumptions of free body diagram. What were the assumptions, students? So I told you. Yes. Okay. Very nice. Very nice, students from North Canada. Very good. Okay. Very good. So what were the assumptions? First was body is assumed to be a point mass. Let's say if you're taking this is our body over here. Let's say this is our total body. That is the box of mass m. So we can take it as what? A point mass of m mass. I told you that these are assumptions. See, when solving problems, you need not, let's say if you're solving this problem, you need not convert it into point mass, then solve it. Okay. Okay. The thing is, these are assumptions that are made, and you need to understand it when you're solving it. Okay. It need not be followed, but you need to make sure that you understood it. Okay. So when solving problems, don't do this step by steps. If you know, do everything. If you know the forces that are acting, do quickly, be quick. Okay. Then what? We have to show the forces acting on the body. You know that. What are the forces acting on the body? Let me know. What are the forces acting on the body? The first is what? Weight acting on the body. Yes or no? And next is what? There was a normal force that was acting, and it was S. N. Okay. Is it NMS or NSM? We want force. We want force on the body. We want force on the body. Yes, very good, very good. So what? The forces on the body will be from what? See, the surface will provide a force on the body, basically. And for that reason, we write this normal force as what? S and SM. The surface is providing, is applying a normal force on the body. So no? And I told you what? Frame of reference should be what? Ground. The see, frame of reference, like have an idea, थोड़ा मोटा मोटा आइडिया ले लो कि फ्रेम ऑफ रेफरेंस होता है कि फ्रॉम विच पॉइंट यू आर ऑब्जर्विंग. ठीक है, जो भी आप ऑब्जर्व कर रहे हो, मान लो इस चीज को जो ऑब्जर्व कर रहे हो वो आप ग्राउंड में रहकर ऑब्जर्व कर रहे हो ना. आप भी ग्राउंड पे हो, है कि नहीं? तो ग्राउंड पे रहकर आप ऑब्जर्व कर रहे हो, इसलिए आप फ्रेम ऑफ रेफरेंस अर्थ ले रहे हो. ठीक है. सी, जब आप इसके डेप्थ पे जाओगे ना, डेप्थ पे जाओगे, देन यू से दैट अर्थ इज आल्सो नॉट अ इनर्शियल फ्रेम. फ्रेम ऑफ रेफरेंस को, जो ये वाला फ्रेम ऑफ रेफरेंस को इनर्शियल फ्रेम भी बोलते हैं. आई हैव टोल्ड यू इन द लास्ट क्लास. हाउ द स्टूडेंट्स ಹೇಳಿದನಲ್ಲ. So earth, when you go deeper, since I'll tell you why it's not called what? An inertial frame. Okay, not an inertial frame. I'll tell you why. See, first of all, yesterday I told you that inertial frame, basically inertial frame is a frame where what? Newton's first law hold or laws hold. Okay, first law hold. See, अगर न्यूटन फर्स्ट लॉ होल्ड करनी चाहिए तो इसका मतलब क्या है कि फोर्स जो होता है एफ नेट इक्वल टू जीरो होता है ना. Yes or no, students? Let me know. F net is zero. What does it mean? the total force acting on the body should be what? The net force acting on the body should be 0. Yes or no? Let me know, students. Jaldi. The net force acting हाँ should be 0 है कि नहीं? हाँ. अगर नेट फोर्स 0 है, इसका मतलब क्या है कि एक्सेलरेशन 0 है ना. हाँ सही है. लेकिन जब हम अर्थ को जनरली ऐसे मानते हैं कि अर्थ को इनर्शियल फ्रेम मानते हैं, ठीक है. बट व्हेन यू गो डेप्थ, मच मोर डेप्थ, जब हम पढ़ेंगे, डोंट वरी, विल बी टॉकिंग अबाउट इट व्हेन वी टॉक अबाउट ग्रेविटेशन, स्पेशल थियरी ऑफ रिलेटिविटी, ये सब जब पढ़ेंगे ना तब डीप में जाएंगे. लेकिन यहाँ थोड़ा आइडिया रखो. अर्थ बेसिकली रोटेट्स है कि नहीं? रोटेट होगा ना. रोटेट होने की वजह से एक एक्सेलरेशन होगा, एक वेलोसिटी होगा, तो क्या होगा? एक्सेलरेशन होनी चाहिए ना. लेकिन क्या करते हैं बेसिकली, जो एक्सेलरेशन होता है ना, अर्थ का एक्सेलरेशन को नियरली 0 मानते हैं. इसी वजह से वी टेक अर्थ एज इनर्शियल फ्रेम. ठीक है? इज इट गुड? ठीक है. तो इसलिए हम मानते हैं, अभी जो मानते हैं कि ग्राउंड को और अर्थ को इनर्शियल फ्रेम मानते हैं. इनर्शियल फ्रेम. ಓಕೆ ಅಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್, ಅರ್ಥ ಆಯ್ತಾ? ಏನಾಗ್ತದೆ ಅಂದ್ರೆ, ಅರ್ತ್ ನಾವು ಇನರ್ಷಿಯಲ್ ಫ್ರೇಮ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ, ಆಯ್ತಾ. ಬಟ್ ನೀವು ಡೀಪ್ ಆಗಿ ಹೋದಾಗ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ, ನಿಮಗೂ ಗೊತ್ತಿದೆ ಅರ್ತ್ ರೊಟೇಟ್ ಆಗ್ತಿದೆ. ಬಟ್ ಅರ್ತ್ ರೊಟೇಟ್ ಆಗೋದು ಅದಕ್ಕೆ ಒಂದು ವೆಲೋಸಿಟಿ ಇದೆ, ಒಂದು ಆಕ್ಸೆಲರೇಷನ್ ಇದೆ. ಬಟ್ when you talk about the acceleration of the earth, it will be nearly 0, ಆಯ್ತಾ. ನಿಯರ್ಲಿ 0 ಇರುತ್ತೆ. ಸೊ ಅದೇ ಕಾರಣದಿಂದ ಈಗ ಏನಾಯ್ತು, ನಿಯರ್ಲಿ 0 ಇದ್ರೆ ಏನ್ ಅರ್ಥ? ಫೋರ್ಸ್ 0 ಆಯ್ತು, ಹೌದಲ್ವಾ? ಆಕ್ಸೆಲರೇಷನ್ 0 ಅಂದ್ರೆ ಫೋರ್ಸ್ 0 ಆಯ್ತು. ಫೋರ್ಸ್ 0 ಆದ್ರೆ ಎಂತ ಆಯ್ತು? ನ್ಯೂಟನ್ಸ್ ಲಾ ಹೋಲ್ಡ್ ಆಗ್ತದೆ. ನ್ಯೂಟನ್ಸ್ ಲಾ ಹೋಲ್ಡ್, ಹೌದಲ್ಲ? ನ್ಯೂಟನ್ಸ್ ಲಾ ಹೋಲ್ಡ್ ಆದ್ರೆ then it is called what? Inertial frame. Then it is called inertial frame. Is it good? Students, let me know. Students from all the JNVs, let me know. Okay, very good. Prithvi, JNV Yanam, welcome to today's class. Prarthana from Davangere, good evening. Welcome to today's class. Krishna, very good. Thank you. Okay. Okay, students. So we had talked about these many things. Okay. So you know how to draw the forces, how to calculate yeah, Prarthana, good evening. So how to do it? Yes or no? And Harish, yes, Harish, good evening. Okay. So I hope you're doing well. Very good. Now, talking about what in free body diagram, as I said, now I talked about it. What? Newton's first law is not true in all frames. Okay. As I said, Newton's first law is not true in all frames, but we consider reference frame in which is true. Okay. Is it good? And that frame is called inertial frame. We consider frames where what? Newton's law hold. Or as I said, frame of reference frame is basically frame from where you observe things. Okay. मान लो वो ग्राउंड हो सकता है, ऑब्जर्व थिंग्स. बेसिकली उसमें क्या होता है? एक्सेलरेशन 0 होता है ना. एक्सेलरेशन 0 मतलब क्या? आप ग्राउंड में हो सकते हो, या कार में बैठे हो, वो भी 0 होगा, या प्लेन में बैठे हो. आपका जो रेफरेंस फ्रेम है, आपका फ्रेम है, जिस तरीके से आप ऑब्जर्व कर रहे हो, वो तो उसका एक्सेलरेशन से 0 है ना. मान लो प्लेन में बैठे हो, ठीक है, वो ट्रैवल कर रहे हैं, लेकिन आप इफ यू क्लोज योर आईज, then you feel what? You feel that you are not moving at all. Yes or no? That is your observing frame. That is called frame of reference. Is it good? Students, let me know. Very good. Okay. Yes. Good. Now, if that is the case, students, then we talked about equilibrium of a system. What did I call about equilibrium? Let me know. In equilibrium of a particle of a system refers to the situation where the net external force acting on the system is 0. So no, what did I say? The net external force acting on the system is 0. मतलब अगर मान लो एक बॉडी है, ठीक है, एक बॉडी था, हमने कल भी देखा था. सुषमा, गुड इवनिंग. कल भी देखा था, अगर मैंने यहाँ फोर्स लगाया तो ये बॉडी मूव करेगा. लेकिन अगर मूव, if you want to stop the body to move, we apply a force. Yes or no? And you got that F net equal to क्या होगा? f net is equal to f minus f which is equal to 0. बट मैंने अभी बोला कि अगर मान लो इसको x डायरेक्शन मान लो और इसको y डायरेक्शन मान लो, ठीक है, इसमें भी क्या होता है कि y डायरेक्शन में कुछ हो रहा है क्या? y डायरेक्शन में मासेस जंप कर रहे हैं क्या? नहीं ना. So if that is the case in equilibrium of system, it means that the net force in x direction should be 0, the force in y direction should be 0, and also if you take x, y, z as your coordinate system, मतलब तीनों जगह, okay, x, y, z में, okay, then students, then your z direction forces should also be 0. मतलब z direction में जो भी net force होता है, the sum of forces should be 0. है कि नहीं? Let me know, students. Let me know. Yes. Is it good till now? Okay, Suman, very good. Others? Okay, so many have joined. Thank you. Ansari, good evening. Okay, very good. Awesome. Okay. Now, if everything is clear, then did you solve yesterday's problem? Let me know. Did anyone try to solve yesterday's problem? The problem was over here. It said that a block of mass 5 kg is suspended with two strings. Okay, 5 kg का एक block है which is suspended with two string as shown. Find tension in each string. Okay, आपको tension find out करना है, ठीक है? Let me know in this setup, in the whole setup, are there two strings या one string है? जब आप इस setup को देखते हो, इस setup ಅನ್ನು ನೋಡಿದಾಗ ಏನ್ ಅನ್ಸ್ತದೆ? ಇದರಲ್ಲಿ ಎರಡು ಸ್ಟ್ರಿಂಗ್ ಉಂಟಾ, ಒಂದು ಸ್ಟ್ರಿಂಗ್ ಉಂಟಾ? ಅಬ್ಬೈ, ವೆರಿ ಗುಡ್. ಲೆಟ್ ಮಿ ನೋ. ಅದರ್ಸ್? ಈಗ ಒಂದೇ ಸ್ಟ್ರಿಂಗ್, ಎರಡು ಸ್ಟ್ರಿಂಗ್. ವೆರಿ ಗುಡ್, ವೆರಿ ನೈಸ್. ಸೊ how many strings are there? This is one string, this is second string. Now students, you need to find what? You need to find the tension. You need to find the tension. So I'm giving you, let's say I'll give you 3 minutes of time to solve this problem. Okay, I'll give you 3 minutes of time to solve this problem. So please try to solve this, and I want to know what is the tension in both the strings. Okay, so here is the time, students. The timer has started. Please start solving it. Okay, and let me know what is the value of T1 and T2. Okay, what is the value of T1 and T2? What is the value of it? Let me know. Jaldi. Okay. I hope you remember how to, let's say, take the direction of tension. Okay. Here, students, one minute. This is 53 degree. Okay. This is 53 degree. Abhay, that you need to find it out. See, I have told you how to find the how to do the FVD. So what you need to do, solution में आपको पहले FVD बनाओ. FVD से आपको पता चलेगी क्या करना है. पहले वो करो. FVD बनाओ. Everyone. Panthan, are you trying it? Divya, let me know. Very nice. So last 1.5 minutes. If you're able to solve this, then it's pretty good. And I have also given, okay Amit, I also given a hint for the angle. Okay, this is the hint for angle. I hope students remember this always. Okay, remember this. Everyone is trying. Harish, are you trying the problem? Let me know. Everyone, okay. Everyone, are you trying the problem? Let me know. Or are you able to do it? Sandeep, please join using the audio. Otherwise, you won't be able to listen to me. Okay, Path, very good. Okay, bhai. Others, students from JNV, Bagalkot, Ballari, North Canara, Yanam. Are you guys driving? Davangere students. Prithvi, let me know. Okay, the time is up. Should I give you extra time? एक्स्ट्रा टाइम तो चाहिए तो पूछ लो, वरना मैं स्टार्ट कर लूंगा सॉल्व करने के लिए. बताओ, टाइम ಬೇಕಾ एक्स्ट्रा? ಬೇಕಿದ್ರೆ ಹೇಳಿ, ಇಲ್ಲ ನಾನು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಓಕೆ. Yes, students from JNV Yanam, yes, you can get previous class session from YouTube. Go to Avanti Live 5. Avanti Live 5. You will get all the videos over here from yesterday's session also. Is it good? Let me know. ठीक है ना? Okay. No problem. No problem. Yes. Okay. Okay. Ha. Now talking about this problem. Okay. See over here, there is two strings that is given. We already identified it. Now students, let me know, अगर इस पॉइंट में रुकूंगा तो where will be the tension? यहाँ होगा ना, टेंशन यहाँ होगा. और मैं यहाँ रुकूंगा तो यहाँ टेंशन होगा. And if I'm over here, the tension will be over here. Yes or no? T. Now you know that, and if I'm standing over here, the tension will be over here. Yes or no? We already talked about it. Now, as I said, there are two strings. So I'll name it as T1, and I'll name is a T2. Okay. Now when you're doing FBD students, you know that there is a body of mass, okay, M, which is 5 kg. Okay, now you know that there will be a weight acting downwards, which will be what? Which will be 5 into, let's take, okay students, my bad, let's take G to be 10 meter square, meter per second square. है कि नहीं? Meter per second square. Is it good? mg, ha. Okay, meter per second square. Is it good? Change in velocity. Okay. Now, can I take this weight as 5 into 10, which is equal to 50 Newton? Can I take this? Yes or no? You need to convert into weight. Weight will be converted into Newton. Then, yes, very good. Now, students, there are two tensions that are acting. The first tension is acting over here. That is what? T2. Yes or no? Then there is a tension acting over here. That is what? T1. Yes or no? Is it good? ये वाला बन जाएगा ना आपके साथ. ये वाला जो FBD, did you were you be able to do it? And let's say, did you do it? Were you able to do it? Let me know, students. Yes. Okay. Now let us redraw it. As I said, there is what? Let's say there is a body of mass M. Okay ना? उसके बाद हमारे पास एक weight है नीचे जाने वाला. Okay. Then as I said, there is a tension over here, and also I said there is a tension over here. ठीक है? आप देखो. अब यहाँ मैं क्या करूँगा? I'll extend this. ठीक है? I'll extend this, and I told you that this is what? This is weight. This is weight, which is what? 50 Newton हो गया. अब ये जो टेंशन है ये T1 है, और ये जो टेंशन है ये T2 है कि नहीं? Let me know, students. Now I'll extend this also. Okay. Now you know that over here, अभी ये जो दिया है ये वाला एंगल 53 डिग्री है. अगर ये वाला 53 डिग्री है तो ये वाला भी 53 डिग्री हो जाएगा ना? ऐसा नो स्टूडेंट्स, लेट मी नो. अभी है कि नहीं? है कि नहीं? लेट मी नो स्टूडेंट्स, जल्दी. रिजॉल्व कर दिया मैंने. ऐसा नो? अगर मैंने 50, हाँ वेरी गुड, अगर इसको 53 डिग्री बना दिया, अब मान लो ये वाला x है, ये वाला नेगेटिव x है, ये वाला y है, ये वाला नेगेटिव y है. ठीक है? अब ये मान लिया. अब मैं इसको कंपोनेंट में रिजॉल्व कर सकता हूँ क्या? अब कंपोनेंट में रिजॉल्व करूँ तो व्हाट? रिजॉल्विंग the components, resolving the components, मुझे ऐसा कुछ मिल जाएगा क्या? T2 cos 53 एंड ये वाला T2 sin 53 मिल जाएगा क्या? यस अबे, वेरी गुड. हाँ, वेरी नाइस, वेरी नाइस. यस. हाँ, अब देखो, अब एक्स एक्सिस में एक आ गया, वाई एक्सिस में ये एक आ गया. आपको पता है कि ये इक्विलिब्रियम में है. इट इज इन इक्विलिब्रियम. As I said, if I'm not giving in question, you should what? Assume that it's in equilibrium. Then you know that force in x direction is zero and the total force acting in y direction is also zero. है कि नहीं? अब मान लो पहला वाला जो x डायरेक्शन में जीरो है, तो मैं ऐसा ले सकता हूँ क्या? ये वाला T1 पॉजिटिव एक्सिस में है, तो T1 ओके, दिस इज इन नेगेटिव डायरेक्शन, माइनस T2 cos 53 डिग्री, है कि नहीं? then is equal to 0. So can I write this as T1 is equal to T2 cos 53 डिग्री. अब आपको पता है कि 53 डिग्री cos 53 क्या होगा? ये जो होगा ना, ये cos 53 डिग्री, इसमें क्या होगा? लेट मी नो, जल्दी जल्दी जल्दी. 3/5 या 4/5 है? जल्दी बताओ. 3/5 है ना? वेरी नाइस. तो क्या होगा? T1 is equal to T2 into 3/5. ये हो गया हमारा पहला वाला. ऐसा नो स्टूडेंट्स, लेट मी नो, जल्दी बताओ अभी. लेट मी नो स्टूडेंट्स, है कि नहीं? वेरी नाइस. यस. अब देखो, अब आएगा एक और. अब होगा, आपको ये भी पता है कि इक्विलिब्रियम में होगा तो व्हाट, तो आपका एक वाई डायरेक्शन भी जीरो होगा. तो वाई डायरेक्शन में जीरो होगा तो क्या क्या आएगा? ये वाला आएगा और ये वाला ऊपर वाला आएगा ना. एंड यू नो दैट व्हाट, sin 53 कितना आ जाएगा? sin 53 डिग्री इज व्हाट? 4/5 आएगा, है कि नहीं? Now you know that this is in negative direction, this is in positive direction. Then what? T2 sin 53 degree minus 50 Newton is equal to 0. T2 sin 53 degree is equal to 50 and 53 degree was 4/5 which is equal to 50. 52 क्या वैल्यू क्या होगा? 5 into 5 into 50/4, है कि नहीं? Which is equal to कितना आ जाएगा ये? 250/4 and we get what? 125/2 आ जाएगा, है कि नहीं? So the value of T2 is 125/2. ये आ गया. Okay, who is this? Abhay. Okay, Abhay, as I told you, see, I told you that the angle that was given was 53 डिग्री, है कि नहीं? अगर मुझे 53 डिग्री है तो आपको भी पता है ये फेमस ट्राइंगल है कि नहीं? ये फेमस ट्राइंगल है ना. आपको पता है कि ये वैल्यू 5 है, ये वैल्यू 3 है, 4 है, ये वैल्यू 3 है. आपको ये वाला याद रखना पड़ेगा. आपको ये वाला भी है 37 डिग्री, ठीक है? तो 37 डिग्री का क्या होगा? 5, 3, 4. इसके हिसाब से मैंने साइन और कॉस की वैल्यू पता चला. वेरी गुड, नाइस. ओके, नाइस स्टूडेंट्स, वेरी गुड. अब देखो, अब मुझे T2 की वैल्यू पता चला. नाउ यू नो दैट व्हाट, ये वाला आपको पता है ना क्या? T1 इक्वल टू T2 इंटू 3/5. T2 वैल्यू क्या था? T2 वैल्यू था 125. जस्ट अ सेकेंड. 125/2 इंटू व्हाट? 3/5. इसका वैल्यू क्या होगा? लेट मी नो स्टूडेंट्स, अब बताओ. अब मैं इसका आंसर नहीं बताऊंगा, आप बताओ इसका वैल्यू क्या आएगा? जल्दी जल्दी बताओ. लेट मी नो स्टूडेंट्स. यस, वेरी गुड. इसका वैल्यू क्या आएगा? 75/2 आ जाएगा ना. सो दैट इज व्हाट. सो therefore the value of tension are very nice. T1 क्या आएगा था? 120. सॉरी, T2 आया था 125/2 and T1 आया था 75/2. इज इट गुड? लेट मी नो स्टूडेंट्स, आपका जो आंसर है ये आता है, पता चला कैसे करना है आपको? लेट मी नो स्टूडेंट्स. Okay, all the students, let me know in the chat. Very nice. Harish, very good. Nevanand, okay, very good Harish and Nenavant. Ganesh, very good. कुछ डाउट है? Let me know, students from YouTube live. Is there any doubt? Let me know in the chat, okay? Okay, good students. If that is the case, if everyone has understood, Jivan, yes, thank you. Sushma, okay, you didn't understand it? Sweetie, okay, okay. Others, let me know. Okay, sweetie. Here, see, ये जो सिस्टम है ना, जो मैंने ये वाला बताया, ये जो सिस्टम है वो ऑलरेडी इक्विलिब्रियम में है, ठीक है? आपको पता है कि अगर इट्स इन इक्विलिब्रियम, स्वीटी, यू नो दैट द सम ऑफ x forces and y forces, डायरेक्शन ऑफ फोर्सेस इन x एंड y डायरेक्शंस आर जीरो. देखो, अब आप मान लो ये वाला जो है ना y है, y प्लस y है, और ये वाला नेगेटिव y है. तो आपको पता है कि अगर ये वाला जो देखो, एक इट्स इन टू डिफरेंट डायरेक्शन है, सर नो? नाउ इफ आई एम टेकिंग दिस एज द पॉजिटिव डायरेक्शन, कैन आई राइट दिस एज t2 sin 53 डिग्री, और ये नेगेटिव डायरेक्शन में, तो -50 इक्वल टू 0 आ जाएगा ना? बस यही था, और कुछ कुछ भी नहीं था. इज इट गुड स्वीटी? ये वाला पता चला या और भी कंफ्यूजन है? बता दो मुझे, फिर आपको क्या करना है. Okay, Sushma, no problem. Okay, then what you do? You write T2 sin 53 degree equal to 50. Then using the triangle, you find out what is the value of T2. T2 value आया था 125/2. पता चला? Let me know. Okay, sweetie, very good, very nice. So if that is the case, students, if everyone, okay, clear, very nice. If everyone has the problem cleared, then here is another numerical. Here is another numerical. Please remember the system is in. Okay, Sushma. Arey, thank you, Parth. Okay, is in equilibrium. ठीक है? ये वाला equilibrium. Okay, students. So अब solve करो. अब आपको 3 मिनट फिर से दूंगा. ये सिमिलर है, बहुत ही ज्यादा सिमिलर है प्रीवियस प्रॉब्लम से, ठीक है? तो अब कर लो, एक बार ट्राई कर लो. 3 मिनट दूंगा. Okay, I'll give you 3 minutes. And students from JNV, I'll ask the answer from you guys now, because others are answering and you guys are not. So be ready. So students from North Canara, Ballari and Bagalkot. Okay, and Davangere students, be ready with your answers. Okay, ಎಲ್ಲರೂ ready ಇರಬೇಕು ಈಗ ಆನ್ಸರ್. ಇದರಲ್ಲಿಂದ ಮಾಡಬೇಕು, same thing, you need to find the tension. Okay, the timer will start now. So please answer, students. So you need to find the tension. ಈಗ ನಾನು ಹಿಂಟಿಸ್ ಕೊಡುದಿಲ್ಲ ಎಷ್ಟು ಟೆನ್ಷನ್ ಇರ್ತದೆ ಅಂತ. ಓಕೆ ಓಕೆ, ಹರೀಶ್ ಅಂಡ್ ಗಣೇಶ್, ಪ್ಲೀಸ್ ಟ್ರೈ ಇಟ್ ನೌ. Ganesh, class notes of Avanti. Let me know, Ganesh. And students, solve it. I'm giving you 3 minutes of time. I already gave you. So you know the hint also how to solve it. And if you want, I can give extra time also. But I want everyone to try it. Huh. So Ganesh, what we are doing is we are setting up a Google Drive where we are uploading every note. Okay, so we are collecting from different faculties that have done the classes. So it will take a time. After that, we'll be sharing it over here. Okay, then you will get the access to that material. Is it good? Give us little days of time. By the end of next week, everything will be sorted and you will be able to find all the materials, PDFs and all. Okay. Yanam, let me know which tension you are talking about. Let me know the value that you wrote is for which tension. Okay. Check your answer once. Did you convert the weight into Newton? Did you convert the weight into Newton? It's in 10. Yeah. Let me know, Janvi Yanam. Abhay Gupta. Yeah. Abhay Gupta, you need to find the tension value. I thought you were talking about other things. Okay. So yeah, also take G as what? 10. Okay. G as 10. Okay. Manthan. Okay. Very good, Manthan. Just a second. No. Okay. Manthan, very good. North. Okay. Students from North Canada, very good. Manthan, you saw the, I mean, you got right. Where did you do the mistake and all? There was certain mistake in your answer. Very nice. Wait, Manthan, please check your answer once. There are two answers from you, so please check your answer once, okay? Okay. So, should I start solving it? Let me know, students. Should I start solving it, or should I give you much more time? Let me know in the chat. Okay. Ganesh, are you trying it? He started, sir. Okay, solve it. Okay, good. No problem. Okay. Now, okay, Abhay, I'll be solving it. Okay. Now, the solution of it. Okay. When you're trying the solution of it, the first thing you need to do the FBD of it. Okay. When you do the FBD of it, you know that, see, over here, there is one mass. What? Ek mass hai, which is of 10 kg. And you know that there is one tension over here, and there is a tension over here. You know the direction of the tension is what? From this point. आपको पता है कि T2 है और ये T1 है. It's already given. It is in what? 30 degree. Yes or no? देखो. Now you need to draw this as something like this. You know that this is the weight that is acting, and this is what? What? 10 grams, and you know that 10 G, and that is what? 10 into 10, which is equal to 100 Newton. मैंने G का value मैंने ले लिया. Yes or no? And you know that over here there is a tension that is acting in this direction, T2. Sweetie, okay, very good. And there is a tension acting in this direction, that is T1. And also there is this 30 degree, that is the value, that is the theta value. Now students, carefully observe. I'll draw it again over here very nicely. This is there are three values that has to come here and over here. ठीक है. अब देखो, ये वाला क्या था? वेट था, विच आया 100 न्यूटन. ये वाला क्या था? टी. ये T2 था ना, ये T2 था. ये वाला क्या था? ये वाला T1 ना, T1 था. अब इसको मैं एक्सटेंड करूंगा तो ये क्या होगा? ये 30 डिग्री है. देखो, अभी जो मैंने लास्ट इसमें किया था, आपको इसको रिजॉल्व करना है इनटू टू कंपोनेंट्स. ठीक है. अब ये मान लो कि ये एक्स डायरेक्शन है, ये वाला वाई डायरेक्शन है, ये पॉजिटिव है, ये पॉजिटिव है, ये वाला नेगेटिव एक्स है, ये वाला नेगेटिव वाई है कि नहीं? नाउ कैन आई like resolve into two components, that is T2 ये वाला sin 30 है और ये वाला T2 cos 30 है. लेट मी नो स्टूडेंट्स, यहां तक तो क्लियर है? ये वाला क्लियर है? लेट मी नो स्टूडेंट्स. यस, अदर्स, ये वाला क्लियर है ना? ओके. अब देखो, जब आपको पता है कि इक्विलिब्रियम में है तो summation of fx is equal to 0 and summation of fy equal to 0. ये आपको दोनों पता है आपको. तो पहला वाला लूंगा, summation of fx ले लूंगा. ओके पाथ, नो प्रॉब्लम. ओके अब देखो, आपको पता है कि x डायरेक्शन में लेना पड़ेगा आपको. पहले अगर फोर्सेस x डायरेक्शन में ले रहे हो, then you know that this is in positive x-axis and this is in negative x-axis. Then can I take t2 sin 30 minus t1 equal to 0? है कि नहीं? Then what? t2 sin 30, ये वाला sin है ना, या sin 30 equal to t1. Let me know what is the value of sin 30. जल्दी बताओ, sin 30 का वैल्यू क्या है? 1. हाँ, others very good. So t2 sin 30 का वैल्यू है, सुमन, is it root 3 by 2 or 1 by 2? Is it root 3 by 2 or 1 by 2? 1 by 2 है ना, is equal to t1. Very nice. So इसका क्या होगा कि t2 equal to what? 2 into t1 हो जाएगा, है कि नहीं? हमारा पहला वाला मिल गया हमें. ओके हाँ भाई, वेरी गुड. अब आएगा, यस मंथन, वेरी नाइस. सो यू वांट व्हाट? यू वांट द फोर्सेस इन वाई डायरेक्शन. जो फोर्सेस इन वाई डायरेक्शन है वो ये वाला है और ये वाला है. आपको पता है कि ये नेगेटिव में है तो ये नेगेटिव आएगा, ये पॉजिटिव में आएगा तो ये पॉजिटिव में आएगा. तो व्हाट विल बी द वैल्यू? इट विल बी t2 cos 30 degree minus 100 equal to 0. Then t2 cos 30 कितना होता है? root 3 by 2 होता है, is equal to 100. So t2 वैल्यू क्या आएगा? t2 वैल्यू क्या आएगा हमें? which is equal to 200 by root 3. ये वाला आएगा. Now you know that t2 equal to क्या है मेरे पास? 2 into t1. So therefore t1 equal to t2 divided by 2 and t1 equal to क्या होगा? t2 है 200 by what? root 3 into 2 and t1 आएगा क्या वैल्यू? 100 by root 3. ये वाला आपका जो आंसर है. पता चला आपको? अब पता चला आंसर? लेट मी नो स्टूडेंट्स. Okay, very good, Manthan. Others, let me know from other JNUs. Bagalkot students, Ballari students, North Canada students, let me know. Parth, Manthan, Prarthana, Sushma, Sweetie, Krishna, Suman, clear. Okay, good. Okay, Harish and Ganesh, let me know. Very good. Nice. Clear. Very good. अगर ये सब क्लियर है तो एक और प्रॉब्लम करे क्या? वेरी नाइस. ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬಹುದಾ? ಓಕೆ ಪಾತ್, ವೆರಿ ನೈಸ್. ಹಾ, ಓಕೆ, if that is the case, then here is another numerical students. Now again, okay, ಮಾಡಬಹುದು. Okay मंथन, very nice. So I'm just giving you थोड़ा लेस टाइम दूंगा, 2 minutes 30 seconds दूंगा, ठीक है? इतना टाइम ही दूंगा अभी तो, क्योंकि आपको 2 प्रॉब्लम सॉल्व हो चुका है, तो आपको पता है कि क्या करना है अभी, तो जल्दी करो, ठीक है? 2 minutes and 30 seconds. And here it is. So please solve it, students. जल्दी सॉल्व करो. इसमें भी मान लो, हाँ, G10 ले लो और इक्विलिब्रियम में है, ठीक है? जिस 10 मीटर पर सेकेंड स्क्वायर, ठीक है? जी की वैल्यू इक्विलिब्रियम में है बॉडी. Okay, Harish, very good, very nice. Okay, ಎಲ್ಲರೂ ಟ್ರೈ ಮಾಡ್ತಿದ್ದೀರಾ? Okay, Sushma. Thank you. FVD करना है पहले. FVD ಮಾಡಿ ಫಸ್ಟ್ ಗೆ ಮತ್ತೆ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಓಕೆನಾ? FVD ಮಾಡಿದ್ರೆ ಇದರಲ್ಲಿ ಇನ್ನೂ ಈಸಿ ಆಗುತ್ತೆ. If you do FVD, it's much more easier here. So I'll give you 30 more seconds, okay? So that you are able to solve it. अरे 80√4. ओके, 80√4 आएगा. देखते हैं, ठीक है. Others, let me know the answer jaldi. Okay, √3 sir. Okay, T1 is equal to 40 and T2 is equal to 80√3. Okay, nice path. Sweetie, okay, nice. इतना आएगा क्या? Okay, let's check it. Okay, students from JNV, let me know. Solve ಮಾಡಿದೀರಾ? Try ಮಾಡಿದೀರಾ? JNV students, let me know. ಬೇಗ solve ಮಾಡಿದೀರಾ? Did you even try? Solve ಮಾಡ್ಲಿಕ್ಕೆ try ಮಾಡಿದ್ರಾ? Others, I'll ask people. Okay, ನಾನು ಮತ್ತೆ ಕೇಳ್ತೇನೆ solve ಮಾಡಿದ್ರಾ ಇಲ್ವಾ ಅಂತ. Okay, Sushma. Okay, let's try to do it. Okay, let's try to do it first. Over here, you know that if I'm drawing the FBD of it, I'll go a little faster over here. If you draw the FBD of it, this is the what? T2 also 80√3. Let's see. Okay, over here, you know that there is a weight acting. That is what? 2G. Now, can I write it as 20 Newton? Students, let me know. And also, there is what? Let's take this as the axis over here. You know that there is a tension acting over here at both the ends. Yes or no? Ha, there are tension acting over here. Yes, Sushma. Yes, because what? G we are taking to be 10 over here. There are tension acting on both the ends. Or let's say we'll take the tension to be in this direction. And the tensions will be different. T1 and T2. Now you know that this is what? 60°. And you know that there is an axis over here. And this is what? 30°. Sir, in W we can't take mass. Can't take mass. हम वेट को कंसिडर करते हैं ना, ये वेट है ना, तो वेट को आपको न्यूटन में कन्वर्ट करना पड़ेगा. स्वीटी एंड अभय. So when you're trying to solve the problems, m is mass. हाँ, m is mass. Yes, Sushma, let me know. Okay, let me know. हाँ, लेकिन जब आप कन्वर्ट करते हो ना, जब न्यूटन में कन्वर्ट करते हो, when you convert 2 kg, let's say, into what? Weight, basically. See, this is the mass of the system. It's not talking about the weight of the system. Yes or no? Weight is what? Mass into gram है ना? Mass 2 है ना? Mass is 2 over here. ठीक है ना? That means W is given 2 grams. Yes. हाँ, तो इसकी वजह से that is why weight comes out to be 2 gram. Now when you convert it into Newton, it comes out to be 20 Newton. Yes, Parth. Very good. Yes. So most of you would have done like what do you say? The mistake over here. So make sure that you don't do such mistakes. Okay? Okay, good. Nice. So what is it? 20 Newton over here. Now, students, as I said, we can see over here there is 60 degree and 30 degree. Can I resolve it into two components? That is what? T2 cos 60 degree and T2 what? Sin 60 degree. Similarly, can I let's say result into two components? That is what? T1 cos 30 degree and what? T2 sin 30 degree. है कि नहीं? Yes or no, students? Yes or no? Now, when you talk about the what, when we are equilibrium, we know that in x direction force 0 hai and y direction force bhi 0 hai. This is also true. Now, talking about x direction force, let's take this is the positive x axis and this is the negative x axis. You know that what are the forces? This one and this one. Yes or no? Yes or no, students? These are the two forces over here. Now, if I'm writing for forces in x direction to be 0, then can I write T2 cos 60 degree minus T1 cos 30 degree equal to 0. ये लिख सकता हूं. Non-Canada students, okay. The answer is coming now. Okay. Now, what is the value of cos 60 degree? जल्दी बताओ. What is the value of cos 60 degree? T2 cos 60 degree की value क्या है? Very good. Into 1/2 minus T1 cos 30 degree कितना है? √3/2 है कि नहीं? Now, T1 √3/2 equal to T2/2 है कि नहीं? Now, this 2 and this 2 will cancel out. Then T2 is equal to √3 T1 आ जाएगा. ये वाला हमारा पहला वाला आ जाएगा. है कि नहीं? Now, talking about y direction forces to be 0. जो y direction का forces है ना, वो 0 है ना, उसका क्या होगा अभी? आप देखो, इसमें क्लियरली देखो, y डायरेक्शन में क्या क्या आएगा? ये वाला आएगा 20 न्यूटन, ये वाला आएगा, फिर ये वाला भी आएगा ना. ऐसा नो? Now you know that this is the positive y axis and this is the negative y axis. है कि नहीं? Now these two will add up. These two forces will add up. Yes or no? That is what? T2 what? T2 sin 30 degree. Okay, wait. This is T1. Sorry, this is T1. This one is T1 sin 30 degree. है कि नहीं? Plus T2 sin 60 degree minus was 20. Yes or no? Minus 20. Yes, that is correct, which is equal to 0. Now, what is sin 30 degree? Sin 30 degree कितना है? T1 into 1/2 plus T2 into √3/2 equal to 20. Yes, very good. So T1 plus T2 into √3/2 equal to 20. फिर क्या होगा? T1 plus T2 √3 equal to 40. ये हो जाएगा. Now you know that T2 is what? √3 into T1. फिर T1 plus T2 क्या आएगा? We took -2. Okay. हाँ. √3 T1 into √3 is equal to 40. √3 into √3 क्या होता है? Let me know, students. √3 into √3. So T1 plus √3 into √3 is 3T1 equal to what? Equal to 40 and what? 4T1 is equal to 40 and T1 equal to कितना आएगा? 10 आएगा क्या? ये वाला सही है कि नहीं? T1 10 आएगा ना? Let me know, students. हाँ, अब आपको पता है कि T2 क्या है? T2 is √3 T1. फिर क्या आएगा? So T2 equal to √3 into 10. That is, or you can write T2 as 10√3. है कि नहीं? Let me know, students. ये वाला है ना? ये आपका दोनों का आंसर है. अब पता चला क्या है? अब पता चला कहाँ आपने मिस्टेक किया था या फिर मेरा मिस्टेक है? बता दो, जल्दी बताओ. ಹೇಳಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಏನಿಂದ ಎಲ್ಲಿ ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ರಿ? Overseas. Okay. हाँ, very nice. Sir, why we took -20 in a second equation? Okay, Abhay, I'll tell you. Yes, sir. हाँ. Previous slide. Okay, okay, Ballari students, just a second. I gave the same answer. Manthan, very good. Tension has no dimensions. Okay. Tension has what dimensions now? Let me know, students. Tension ka dimension kya hoga? Let me know this. I'll go to previous slide. Till then, answer me. And I'll answer Abhay your question. Just a second. ठीक है? Let me know what is the value of, let's say, unit of tension. ये मैं भूल गया. Tension की unit क्या है? What is the unit of tension? Unit क्या है? Unit less है क्या? नहीं सुषमा. No सुषमा इल्ला. kg meter per second square. Manthan kg meter per second square ये ಎಂತ ಹೇಳ್ತಾರೆ ಅದನ್ನು? kg meter per second square ಅನ್ನು ಏನು ಹೇಳ್ತಾರೆ? Very good, very good, very good. Okay, I'll just write it. The what? The value, the unit of tension is what? Newton. Okay, is it good? Very nice. The unit of tension is Newton. I'll tell you why now. Okay, but students, let me know. Have you written this slide? Let me know quickly. Yes. Okay. Now, Abhay, see, I told you that here we are taking it as negative y direction. Hai ki nahi? Dekho, if something is going in positive direction and something is going in negative direction, okay, now you take this as 5 and you take as 4. When you do the sum of it, you take 5 minus 4, yes or no? 5 minus 4 hoga na, fir 1 hoga uska resultant jo bhi hai. So similar, if something is going in y direction plus y and something is going in negative y, let's say 3 and let's say 2, what you do? 3 minus 2, which is equal to 1. तो वही मैंने किया इधर. पता चला आपको अभी? Okay, nice. Okay, good. Okay, students. So, okay, before going, okay, so I'll introduce a topic. Okay, a rotation of axis concept. Basically, I'll give a brief introduction, and in next class we'll solve problems based on. Okay, so what does it say? See, what is happening over here is, see, over here there is an what? Inclined plane. Okay, inclined plane. In this inclined plane, there is a mass over here, as you can see. Now you know that whenever, see, over here it is what? It is attached to a let's say structure or a roof with a string, and you know that when you observe from this point there will be a tension. Yes or no? Now in certain problems they will ask, find the tension. Find the tension for it. How will you find it? Let's say, देखो, आपको पता है कि आप पहला चीज क्या करोगे? The first thing you would do is you would resolve it. Yes or no? How to, like, let's say, what are the forces acting on it? The forces acting will be what? Over here it will be what? M into G. Yes or no? The weight acting. And you know that since this is the surface, always remember there will be a normal force acting by the what? By the surface. And you know that there is a tension acting. Abhi, if I'm taking, you know that, let's take, you know that this will be your x-axis, okay, and this will be your y-axis generally when you're taking. Yes or no? If you're taking, I'll draw this over here. If I take this, you know that here, this will be your tension. Just a second. This will be your tension. This will be your normal. And what? This will be your, let's say, weight. है कि नहीं? Yes or no, students? Let me know in the chat box, yes or no. जल्दी बताओ. See, this will be your tension, T. This will be your normal. This will be your weight. Yes or no? Yes or no, students? अभी एक inclined plane में, अगर मान लो ये x axis है, ये negative x axis है, ये y axis है, ये वाला y axis है, negative y है कि नहीं? Students from JNV, let me know. देखो, when you're trying to solve these type of problems, the problem that arises is थोड़ा complicated हो जाता है. ಇದು ಸ್ವಲ್ಪ complicated ಆಗ್ತದೆ ಆಯ್ತಾ. ಯಾಕೆಂದ್ರೆ ನೋಡಿ ಇದು जो ये normal है ना, the normal is basically inclined at an angle theta. Similarly, this one is also inclined at a theta, let's say theta 2. So what you need to do is, when you're trying to solve, you need to resolve into two components over here, normal b, weight b. Is yes or no? Let's say this comes out to be n cos theta and this comes out to be n sin theta. Similarly, this comes out to be w sin theta and this comes out to be what, w cos theta 2. So when you're trying to solve these type of concepts, this is very, very what, it's troublesome. Okay. So what you do is, see, you have a basic axis over here. You have a basic axis. What you do is you rotate just a second. You rotate your axis by an angle theta. So what you do is, for these type of problems, you what, draw a new axis, and that axis you call it to be what, x dash and y dash. Okay, is it good? This will be your x, this will be your y, this will be x minus, this will be a what, y minus. Okay, so this will be your what, x minus, and this will be your minus y. Now when you're trying to solve this type of problems over here, देखो अभी देखो, जो ये वाला है ना, ये वाला डायरेक्टली y dash होगा, ये वाला डायरेक्टली x dash होगा. So the tension will be in this direction, the normal will be in this direction, and the weight will be in this what, in this direction. है कि नहीं? That is what, minus, sorry, w is equal to m into g. Now the resolving component will be just this theta over here. Is it good, students? Is it good? So what you do is, you need to जो complicated एक problem है उसको resolve कर रहे to become a very simple like problem. ये आपको एग्जाम में JEE और नीट एग्जाम में बहुत काम आएगा. ठीक है, JEE एंड नीट, इसके बारे में हम नेक्स्ट क्लास में पढ़ेंगे. इज इट गुड स्टूडेंट्स? आइडिया आ गया कि रोटेशन ऑफ एक्सिस कॉन्सेप्ट क्या है? रोटेशन ऑफ एक्सिस कॉन्सेप्ट क्या है, पता चला आपको? लेट मी नो इन द चैट. यस, others JNV students, sweetie, let me know. Yes, very good. Okay, Harish, let me know. Very good. Now if that is the case, students, that's all for today. Now before ending today's session, so I'm going to talk about the summary of today's session. In the meantime, please answer the NPS poll. Okay, please answer the NPS poll now. So what and all did we talk about today? See, basically we talked about FBD. In this FBD, we solve numericals. Yes or no? The first thing we did was numericals. I hope you are able to solve any numerical now, any numerical that comes into your hand. Okay. Next, what we talked about, what, rotation of axis, where I gave a basic idea of it, rotation of axis. So in the next class, we will solve problems based on it. Okay, solve problems based on it. Is it good? Very good, very nice. So that's all for today, students. Thank you for attending, and if you have any doubts, let me know. I'll wait for 2 minutes. Okay, thank you for attending. Dhanyavadas. Okay, abhay. Take care. Bye bye. Good night. And YouTube live students, thank you. Okay, good night, Harish.